Greetings, y'all. What's happening? I'm going to be building an amp here in this video, and this is kind of like skipping ahead to the end of the book and reading how it finishes before you start the book. But this here is the finished product of the amp that I build in this video, and I thought you might want to have a look at it. And the whole point of this video, it's not like it's a spoiler or anything. It's like you want to see the process. So this is the first stage. Got all the components laid out. You can see I have like a Taylor's measuring tape there that one of my faithful tools that I've used over the years. When I first started building tube amps in, I think it was 2013 when my wife and I were living in Bushwick, Brooklyn. I was just determined to do it my own way. And the first amp I built was a 5F1, but I didn't build it from a kit. I studied the schematics and ordered all the parts and built it with the parts that I had bought, and I've kind of just carried on that way ever since, for better or for worse. And you can see here I've used that fancy Taylor's tape to measure the holes and make sure I get them drilled right and all that stuff. And a little bit you'll see the caveman way that I kind of make the chassis cut out for a lay down style transformer like this. So a little ways into making this amp that I'm planning on making here, I got this old really cool Stancor PM8405 power transformer. Check that out. So I'm going to zoom in a little bit. You got a nice low high voltage winding there at the same milliamp rating that you have for like an 18 watt Marshall or something like that. And another, the hits just keep coming. You still got you got 3 amps available on the 5 volt winding, so you can get really down there and use like a 5U4 rectifier if you want to drop a bunch of voltage, because 5x3 will drop some, but you could use a 5U4 too, and maybe you get a little bit different results. Anyway, that you can get it nice and low there. And this transformer made me consider installing a solid state / tube rectifier switch, which I still might do, but I'm just this is what I do, or at least I'm doing it this time. I've already drilled some holes for the power transformer. I got these components in the top panel laid out. Just got the marks made for where I'm gonna use the punch here to make the small indentations to drill the holes out in. And I got some stuff laid out here. Yeah, rough stuff. We'll see what happens with all this, and certain things change. A lot of times I just have things there as placeholders, like these old bias feed resistors, I think you call them, or something like that. Although I think they basically are supposed to be 220K. I think these are 220K, but as you can see, they came out of an amp, and they're not new, which doesn't mean that they're bad, but maybe I should get new ones. This is also not new. This is what's that? It's like an old Russian resistor. Not sure why I have that there. Yeah, that's an idea for like a screen resistor there. I think I have another one here. Same value. Yeah. So those are going to be the screen resistors there. These are pretty tough little buggers, these resistors. You can see I got a bunch of them all over the place. A bunch of Russian stuff here. It's iComrade. I bet the current White House administration would love the components that I have here in this amplifier, at least these Russian pieces. But all joking aside, the Russian stuff from that era, these paper and oil caps here, and these resistors are terrific. And the tubes that they made over there are unbelievably cool as well. So, but the tubes they made in the U.S. and the resistors and components they made in the U.S. at the time were also really nice. So, what are you gonna do? All right, then I've got this as yet to be unused classic tone 18 watt transformer. I think I'm gonna make this a 6v6 amp though. I've used one of these to make a 6v6 amp before. I think it came out pretty good. Main reason being is because I'm building it into this amp, this cabinet, which you can see I got this old Jensen P12N in there. It's like a 1960 or 61, I think. And I want to maybe be a little bit conservative at how hard I'm slapping that thing. So if I, with this secondary here, and the 6v6s, I should be, I shouldn't really be going much past 15 watts, if that at the max. So I think I'll be in the safe zone. Whereas if I had a pair of EL84s in there, even at this low winding, I think they could still get over 15 watts. And, you know, just, I don't know, just getting in the danger zone. I don't know, maybe not. Maybe I'm sound like an old man. If I open my mouth, I sound like a fucking old man. It's about to go.
Casting directors normally dislike being quoted in the press, but one noted candidly, and here, people, is the hooker. The market for masculinity is tight these days. I'll be happy when we go back to ordinary-looking young people. Oh, boy.
Alright, so I like to do this as what I call like kind of a test fitting here. All the parts and how the top control panel is going to look. These chicken head knobs are not even... These are actually old, legit... I can get it here so you can read it. Yeah, there you go. Daco Ware knobs, I think, from Chicago. Yeah, they were pulled off some really old gear. And I kind of cleaned them up with... They're not fully clean. There's still some dirty. You can tell the set screw's a little old, but they're pretty cool, man. And I feel like they feel different in your hand than a newer, more modern knob. They've got a little bit more weight to them, and I mean, like just a little bit. But anyway, this is old, but it's new and hasn't been used yet. As a matter of fact, it even came in the original box. Take a look at that. Yeah, it's pretty cool. There's something that is kind of intriguing to me about these. The presentation of this product is really cool, and the box is cool, and the transformer unused in the box is such a kind of sacred, cool thing. But once you install the transformer, and it's hardwired in there and bolted in, it's not meant to be like taken back out and put in the box. So I would imagine most people just threw these things away, but I can't bring myself to do that. Okay, and tonight I drilled some more holes and got some stuff test fit again. I think I didn't realize that until tonight. I drill these holes, make the holes, and I test fit the components, and I take them out and make more holes. I still have to cut the big hole here for the power transformer to lay down in the chassis, and I got to cut holes for the rubber grommets for the primary and secondary of the output transformer. And I'll have to take all the components out before I do that. I also ordered a couple of 9-pin sockets, or I should say I bought them, and they'll be arriving soon. So once I have those actual sockets, I'll line up the mounting holes in the outside of the socket there, like these are done, and get those holes going. And you know what I'll do? I'll be doing more test fitting. There's going to be holes here too, with terminal strips probably on them, and components flying around in here doing their multi-directional electronic black magic thing they do, or blue magic, you could say. Better than black magic, more interesting, more fun. I think we have some 9-pin tube sockets here for making an amplifier. Oh, that, yeah.
I wonder.
Let's see. There should be 2 Novel tube sockets here. Oh, what's that say? 9-pin brown with short shield. All right. Okay, this is the savage way that I was telling you earlier that I make the cutout in the chassis for the bell cover, the lay down bell cover of the transformer that the wires come out of. So I just kind of drill a bunch of holes and drill smaller holes, and then I take a file and I kind of file away the metal in between where I've drilled the holes, and I keep at it, and it's very crude and savage, and I keep going until I get that piece of metal out of there and I get the actual somewhat rectangular hole out of there. And then I take files and I file down that really crude, terrible rough edge until it's basically smooth and the right size for the transformer to fit in and be mounted on the chassis properly. It's probably my least favorite part of making an amp with a transformer like that. Okay, I'm about to drill the last holes here in the amp for the terminal strips that I'm going to be mounting most of the components on. I've got those 9-pin tube sockets as you saw. Everything's drilled for that. Power cord's going to go there. Fuse will go there. It's going to be a little tight, but I think it'll be fine. This is my least favorite part right there, but I got it done. Output transformer primary, secondary windings will come through those 2 grommets right there. And then look at this mess I make here, man. Once I'm done drilling these holes, I'm gonna clean up this ungodly mess and kind of make it so that I have a clean slate here for when I start actually building the amplifier and soldering the components together. So, all right, that's how the chassis is gonna mount to the cabinet. Those 2 holes right there. I got these dandy little screws, the finish washer. You know. Progress made. I'm gonna take a look. I got the power transformer and the upper transformer mounted to the chassis. Managed to get that hole made for the lay down transformer there. I got these first terminal strips on, and I did some wiring. I've got that's all done. Just a little something. That's not done yet. And I haven't done the primary. I might do that last because this is going to get a little tight over by where the power cord comes in. I'm going to have to drill a hole for the ground of the main power cord. The fuse is going to be right there. So, and I'm about to drill another hole. I'll show you right here-ish to get another terminal strip in here because I forgot about my my signal. I don't know what they're called, like grid feed resistors or bias feed resistors or something like that, but to me they're like, it's like the signal path. So you got your 2 coupling capacitors that are going to come off of I'm still not sure if I'm going to do a long tail pair or a cathode phase inverter with this amp. Either way, it's going to be 2 12AX7s. This one will probably be parallel strapped, and this one is either going to be 1 triode into a cathode phase inverter or a long tail pair. I'm not sure yet. But I do know whatever phase inverter I choose to go with, the signal is going to have to come off of either the plate and cathode or the two plates and travel to a couple of coupling capacitors that will be then connected to these 200K resistors that are actually more like 210 and 208 or something like that. Usually they're going to be 220. A little bit lower is like a little more conservative, I guess. So those will be mounted there on the top part, and they'll be grounded right there. And then from there, the signal will come off of each side and go into the grid of the input grid of each power tube here. And not only will it just go to the grid, but it'll go to the grid via some grid stoppers. That'll be mounted probably right on the tube sockets there. Coming along. So check this out. I'm wiring up the cathode bias resistors that are going to go to the power tubes here. Each tube is going to have its own cathode bias resistor and a bypass capacitor. But I want this to kind of stand up so that the other components can be in there neatly. In order to get it to do that, I'm going to interestingly use this little wild old school capacitor that I pulled out of that old oscillator. All right, and there you go. Thanks, little buddy. Decided I'm going to go with the cathode phase inverter, Tweed Deluxe style. So this amp's really like a mishmash. It's a real mutt. So it's going to have a parallel 12AX7 here that goes into the. It's just going to have that's the input jack, volume and tone. Come back into the grid of the first triode 12AX7 here. That's pins 1, 2, and 3. Which is the plate, the grid, and the cathode. And then it'll come into here come off here, the cathode phase inverter. One half of the signal will come off the plate, pin 6, and the other will come off of the cathode, pin 8. And then that signal will then travel into the input grids of each output tube. And then, the signal will travel via the output transformer wires here, the primary, and it'll come out the secondary. These are the wires that are just going here now to keep them out of the way, but they're going to come over here to the speaker jack. You got the common, the ground there, and the 8-ohm tap. And I don't know if right now it's just drilled for one 8-ohm speaker jack. I want this to be a symbol. All right, I'm in the kind of like the final stage of the assembly here. This amp, doing this I guess you could say kind of it's ended up going the right way. The last thing I'm wiring up here is the input jack, and I'm gonna get this wired up with the 1 meg resistor here. This is gonna go to ground, and it's gonna then go to the parallel strapped 12AX7 here to pins 2 and 7, I believe. The grids there. Everything else is done. I just I did a lot of this last night. I did these last night, the volume and tone controls. Kind of solidified everything in here. Just came up and wired the speaker jack and for the 8 ohm output right there. It's just got a single speaker jack right now. Like I said, I might add another one. I'm not really sure. I have a reasonable idea of how this might sound once I plug it in, and I don't really breadboard stuff. I just kind of wire stuff in there. I guess I do things the hard way, and then I want to see how it sounds, and if I need to change any components out, probably cathode bypass caps and the preamp tubes, or there was cathode resistors or the plate resistors or the coupling caps or whatever. Everything here is pretty solid, and I think no matter how it sounds, like I'm going to probably end up sticking with these individual cathode bias resistors for each, as I say, respective output tube there. So anyway, let's get this going. So I just finished wiring up the amp. I think that's it. The last thing I did here was, where's my trusty chopstick? Was I put this wire here from the input jack to the parallel strapped grid of the first preamp tube. You can see I got this wire right here, which I think is just an excess lead from a resistor that I trimmed, going across to from pin 2 to pin 7. If you want to really get in there, let's see if we can do it like this. There we go. You can see the heater wires there, and then you can see underneath there's a blue wire right there. It goes from 3 to 8 to connect the cathodes to this blue wire. There you go. And then you've got the plate resistor coming off the B plus supply here, going from pin 6 to 1. Yeah, it's all happening, man. And I chose something a little bit different this time. This is a very small detail, but I chose to use this clear heat shrink, so you can kind of see the guts of some of the terminator, you know. How I'll take this wire and I'll wrap it around the lead and solder them together, and then just make sure they're really connected solidly, and then put some heat shrink on them, and you know, the rest is history. All right, so that's the amp, and I'm about to plug it in and see what we got for results here. So let's plug it in. Okay. Turn it on. I got no tubes in it now, but first we're gonna see if the pilot light turns on. It does not. All right, the good news is, remember I told you this pilot assembly was from an old amplifier. Well, I tried to use the old light bulb too, but it was burnt out, so look at that. Yes, it's alive, baby. Woohoo! Here is the finished amp here, and I got it set up so you can see in the meter here the voltages I'm getting and kind of where I'm getting them from. It's from pin 8 of the rectifier. Pretty mellow. I've got 5V4 rectifier in there right now. And then actually I was psyched on these. I got two 6F6 output tubes here, like the Coke bottle shape. I'll take the meter away at the end, you can see them a little bit better. And the plate voltage on those bad boys, I think is like 309, 310, 306, okay. Cool. And then screens, we're seeing nice, mellow, conservative, almost data sheet screen voltage. You know, like when you look up one of those old GE or Tunxol data sheets, and it's like we have experience with like an old Marshall or something. You're not getting that, but look at that. Okay, on the other output tube, and then the plate voltage is okay. And then we'll check out the plate voltages on the 12AX7 preamp tubes over here. I'm not going to move the meter. You might not be able to see my probing as well here, but there we go. That's like the plate of the cathodiene phase inverter triode section of the tube, and then the plate of the gain stage section. It's looking like that. 126.5, and then over here in the parallel strapped input tube, the plate voltages looking like this. So these are some pretty mellow voltages, I would say, overall. And it's really late at night, but the amp sounds super crisp. So I'm gonna move the meter out of the way, and I got the tone all the way up, and I'm gonna turn the volume on my instrument down, which is a Gibson SG, plug straight into the amp. I'll turn the volume up. So listen to this. This is the amp absolutely cranked up through an old vintage Jensen, I think 1960 or 61 P12N speaker. It sounds noisy, but it's not. So I'm going to back it off a little bit, maybe like a quarter of the way. And then just barely turn up the neck pickup in the guitar. Let's switch to the bridge pickup. These are not really effective tests because it's so low, but I'm really kind of trying to show you how the amp is pretty quiet. Let's turn it all the way up actually and go back. It's on the neck pickup. It's gonna be brisk. First little bit of signal we get there. It's wanting to break up. Oops, we'll go back to the neck pickup there. each power tube has its own bias resistor. Let's get this. You can hear my daughter there. 497 ohms in one. They're rated at 500 ohms, so we're just getting the actual accurate readings here. $497 on the other. Okay. Now let's power it up. I got a 5AR4 in there now. I'm going to get some measurements here to determine what our plate dissipation is for these 6F6 output tubes. This amp was made to mostly run 6V6s, but it's kind of a cool, it's also able to run 6F6 tubes too, which is kind of cool. So I'm gonna ground this end here out of the frame, but I'm grounding it to the chassis with an alligator clip. And I'll switch this to DC volts. And I'll see what we got for DC coming off of pin 8 of our rectifier. There we go, 340. Nice. And our plate voltage is 330. Wow, that's like almost like textbook again. 10 volts voltage drop for the 5R4. And our screen voltage is 272. Look at that. That's nice. And that's just like that's like a Lincoln Town Car right there. It's like a Cadillac. So now we're gonna get wacky. And we're going to measure the plates to cathode voltage here. $313. And then we're going to measure the cathode to ground voltage. 18.26. That's for the inside power tube. Then we're going to get plate to cathode voltage for the outside tube. 315, and the cathode to ground 16.95. Do the math and add those together and see what we got for dissipation. I'm going to do a little off-screen math and put the information right there for you. 6v6s in there now. Okay, one last thing here, you guys. I used to make drawings, layout drawings of every amp that I made, and I wouldn't be able to make an amp until I made the layout drawing, but I just kind of stopped making them a while ago, and I've made quite a few amps without making a layout drawing, but I thought it would be fun to make one for this amp, so I kind of did it the opposite way. I made this drawing after I finished making the amp, and it's a little cruder than usual. I don't, my other drawings here, I'll show you. They include the detail of the terminal strips right there to a certain extent. There's another good detail of a terminal strip. Another way that I did it. And on this amp, on this drawing, I didn't add in the terminal strip details. I was just kind of rushing. I was just kind of rushing through it. But that's the circuit, that's the whole amp there. And it gets a little confusing with all the wires crossing over each other. So for the high voltage line, I put these little arrows here so you can see how it goes. And this is also a little confusing too. See, this is a filter capacitor, and that's a cathode bypass capacitor. It doesn't have to be 350 volts. I just use that 'cause that's what I had on hand. And so there you are. That's the layout drawing of the amp.